Hello and welcome. In this video, we're going to talk about normal distribution. If you're a student of data science, statistics, or Six Sigma, it's a must for you to know normal distribution really well. In this video, we'll try to sort out all your concerns related to normal distribution. Whether you're trying to write a quiz or an exam, you will be able to solve those problems with complete understanding and confidence if you follow this video till end. Let's get started. So we have a normal distribution, which is characterized by its mean and standard deviation. Mean is nothing but this red dotted line that you see here on this chart, and standard deviation is responsible for the shape of the distribution. Let's see what happens when we alter the mean. So let's say you had this blue colored normal distribution representation, and it had a mean of 0. If you change the mean to a -5, the normal distribution would not be altered in its shape, but it'll be shifted to the left. Similarly, if you change the mean to a +5, the normal distribution again doesn't get altered in its shape, but it shifts to the right. So mean is responsible for the position of your normal distribution. Then what is standard deviation responsible for? Well, if you remember, standard deviation is nothing but a measure of average deviation from the mean. So let's say this blue curve represents your normal distribution. And if you reduce the standard deviation, what will happen? Standard deviation is the deviation from the mean. When you reduce it, the points will come closer to the mean. So this red curve here represents a scenario where you have reduced the standard deviation. The points are coming closer to the mean. Similarly, this green curve here represents a scenario where the points have moved away from the mean. So when you increase the standard deviation, the points go farther. When you decrease the standard deviation, the points come closer. Since a normal distribution is characterized by both its mean and standard deviation, it is possible that you can alter both at a time. Look at this scenario. So you have a normal distribution curve, which is like this. And then what does this green curve represent? This green curve represents a scenario where obviously the position has been shifted to the right. So the mean has increased, mean has gone to the right. And have the points also gone farther from the mean? Answer is yes. And that's why you see standard deviation is high and the shape of the curve has changed. So with an increase in mean and standard deviation, you get this curve here. With a decrease in mean, we are shifting the mean to the left for this red curve. With a decrease in mean, and what about this? Is there a decrease in standard deviation? Well, yes, the points have come closer to the mean now. So with a decrease in mean and standard deviation, you get this red curve. I hope you understand the influence of both mean and standard deviation on our normal distribution. Let's move ahead. Let's understand the important characteristics of a normal distribution, a very important interview question or a question in exams and quizzes. So it's not characterized by just one or two properties. You have to look at them in entirety. For example, if I ask somebody, tell me a little bit about normal distribution, the first answer is that it's bell-shaped. Well, yes, obviously it is bell-shaped, but just because it is bell-shaped doesn't mean that it'll always be a normal distribution. There are a number of distributions, for example, even a T distribution, which is bell-shaped. It doesn't make it a normal distribution. So bell-shaped, yes, it's one of the properties, but it's not the property which is sufficient all alone to explain the normal distribution. Similarly, people might say it is symmetric. Yes, if it is bell-shaped, it is symmetric. We understand that. But just because it is bell-shaped and symmetric, it doesn't need to be normal distribution. What more? It is asymptotic. Asymptotic means it does not touch the x-axis here. It goes parallel to the x-axis till infinity. This is another property of a normal distribution. Let me give you an example here why I'm saying these properties all alone may not be sufficient to explain a normal distribution. Let's understand this a little better with the help of this example. And you can tell me what properties of normal distribution does it comply with. Would you agree that the shape that I have drawn, let's say I put a line here which represents the y-axis and another line here which represents the x-axis, and I don't necessarily make the red lines touch the x-axis. Can I say this is symmetric? Nearly symmetric. I mean, I've not drawn it very accurately, but I can say it is symmetric, right? Because on both the sides, you have equal area. And it is also asymptotic because I'm not making it touch the x-axis. So just because it is symmetric and asymptotic, this is nowhere close to being a normal distribution, right? So I just wanted to prove this, that we will not go with the properties in a partial sense. We have to look at it in its entirety. Anyway, coming back, another important property is that the mean, the median, and the mode for a normal distribution coincide. Well, interestingly, if you look at the shape that I had drawn just some time back, even that would have the mean, median, and mode coinciding. But that doesn't make it a normal distribution, right? Now, the most important property that everyone should remember about a normal distribution, it is known as empirical rule. Empirical means it is more of an observed concept. It's not something which is to be proven using pen and paper. It's more of an observed thing about a normal distribution. There are interesting observations about the area under the curve in case of a normal distribution as you move certain standard deviations away from the mean. So when you move plus minus 1 standard deviation, it covers certain area. When you move plus minus 2 standard deviation, it covers certain area. We'll be talking about this very soon. But remember, if somebody asks you what is normal distribution and you stop answering this by just saying bell-shaped and symmetric, you've not done your job properly. Now, you may be wondering, what does this blue line represent, right? So there must be some kind of a function. When you put a value of x, you get a value of y here. And because there are continuous values, you have a continuous curve here. Normal distribution is a continuous distribution. It means it can attain any value over a range. What is that function? You don't have to memorize this, and I don't intend to scare you at all, but this is that function. What you have here is the value on the blue curve that you saw, and it is obtained by putting the value of x here. What is this mu? It is the mean. What is the sigma? This is the standard deviation. This is a complicated formula, and you don't have to memorize it, but it's good to know. What is that called? This is called the probability density. So for a given value of x, what is the value on the curve? That's what this function tells you. Anyway, moving ahead, a special case of normal distribution is known as the standard normal distribution. See, I mentioned that a normal distribution is characterized by its mean and standard deviation. Now, there is a possibility that there can be infinite combinations of means and standard deviations, right? So how would you go about coming down to a standard reference? And which is what we always do in life, right? So, for example, when you say something is measured as 1 meter in length, there must be a scale somewhere which is measured as 1 meter. And taking that as a reference, we say that another length is 1 meter. Similarly, when you say something is a normal distribution, is there a standard reference? Well, that standard reference is standard normal distribution. It has a mean 0 and a standard deviation of 1. The table associated with this is what you often see behind all the books. Any statistics book that you will ever buy would always have a few tables at the end. They typically talk about the standard references of these distributions. Now let's quickly pick up the empirical rule with respect to this standard normal distribution. So remember, I said plus minus 1 standard deviation of a normal distribution. So if you move plus 1 standard deviation away from the mean or minus 1 standard deviation away from the mean. Remember, you're not moving mean, you're moving under the curve away from the mean. If you move the mean itself, the curve will shift. But if you move a certain distance away from the mean, you're still covering some distance on the x-axis, which forms an area. Now, this area empirically has been observed to be 68.26% or plus minus 1 standard deviation from the mean. Similarly, if you move plus minus 2 standard deviations away from the mean, you'd be covering 95.46% area under the curve. And if you move plus minus 3 standard deviations away, this is 99.73% of the area under the curve. You can see there's very little white space left here. So it's almost covering the entire region. So these are very important properties of normal distribution, which keep coming back as a reference. And without these, it's very difficult to explain what a normal distribution is. Let's move on to solving a problem now and see how normal distribution is relevant for it. Let's say you're a cricket fan, and historical performance of your favorite batsman shows he has an average score of 35 with a standard deviation of 7. What is the probability that in a given match, he may score less than 20, more than 50, between 25 to 40? Now, this is a simple example, but this beautifully covers all possibilities of questions that you will probably ever get asked in an exam or a quiz. So just pay attention, follow along, and you'll be in a position to solve these questions, not in one, but multiple ways. Let's pick up each of these scenarios one at a time and deep dive as to what is being asked here. So we have some observations. The mean is known to be 35 and the standard deviation is known to be 7. And now there are certain questions which are of the nature less than, greater than, or in between kind of problems. Let's pick up the first problem and try to understand this a little better. First of all, this is our distribution. The mean is 35, and this is how the distribution looks like. Now let's understand what is being asked. The score is less than 20. Okay, so we'll have to draw a line at 20 here. And we'll have to look at the region or the area under the curve to the left, and that looks like this. So we have to find out this gray shaded region here. If you're going to solve this problem using Excel or Python or any other tool, it'll be very straightforward. The formula would have the table baked in and it takes care of it. If you're going to solve this problem manually using the table, then you'll have to first convert these values to the standard normal reference, and then you can look at the table. So let's understand this. How do we do that? The transformation is x minus mu by sigma. X in your case right now that you're looking at is 20. Mu is known to be 35. Sigma is known to be 7. So you have to apply these, convert it to a z value or a standard normal value, and then you have to refer to the value in the table to get the probability. Let's do that. So I'll quickly do that for you in Excel. I'm using it right now only for calculations. Otherwise, we have a formula as well, but I'll just right now use it for calculations. So the value of x is 20. The value of mu is 35. We know that. And the value of standard deviation is 7. So this gives me a negative 2.142 something that goes on. We have to locate this value in the standard normal table. How do we get that? Let's see. So here is the standard normal table. And as you can see, we have various values here. We are looking for a value which is negative 2.14. So you have to locate 2.1 first here, and then you have to find out 4 at the second decimal place, right? So you get this value as 0.01618, as you can see clearly. Negative 2.1 and 4 at the second place. So negative 2.14. This is the value of probability that you're getting. What does it mean? The chance that your favorite batsman would score less than 20 is only 1.618%. I will quickly note down this value here. We got the value from the table, which was 0.01618 or 1.618%, right? There's a simpler way to get this answer straight away, and that is using a formula. So what is that formula? The formula is norm.dist. This has the table baked in. So we have to put some effort to go to the table and find it. But let's say in an exam, you don't have access to Microsoft Excel, then you would not be able to use this. Of course, you'll have to rely on the table only. But if you have access to Microsoft Excel, then you can quickly do this here. You have to put the value 20 straight away. You don't have to do any transformation like this, right? So you can straight away put the value of mean, which is 35, and the standard deviation as 7. And this is a cumulative calculation, so you'll always put a 1 here. See, these values are fairly close. A little different though. Why? Because we didn't follow 100% precision. We didn't really find this value as negative 2.1428571. We only took it till negative 2.14. That's why the answers vary a little bit. But if you look at up to the third place of decimal, the answer is identical. So this is the first type of problem. When they ask you a question related to a less than nature, you straight away go ahead and apply the formula or convert the value to a standard normal form and look for that value in the table, and you will be able to report the answer. Now let's move to the second type of problem, which is what is the probability that the batsman would score more than 50? Now you're talking about a greater than kind of a scenario. Now there's a smart way to answer this, and this is kind of a trick. See, this value is 50, and we know a normal distribution is symmetric. If we go negative 15, 35 minus 15 is 20. And if I go plus 15, 35 plus 15 is 50. So if I already know that the area below this value of 20, the area to the left of this value of 20 is 0.01618, that's what we calculated. If that's already known, that we know the area to the right of 50 will also be same, because this is a symmetric curve. It's a mirror image. I hope you get this. 35 minus 15, 35 plus 15. Since you've moved equal distance away from the mean on either side and the curve is symmetric, if you already found an answer to the values less than 20, that'll be the same as the values greater than 50. But if you don't know this, and if it is not necessarily 50, it may be a value which is, let's say, 47.5, then how are you going to solve this? We're going to look at that. First of all, if we are solving it manually, we will once again have to convert it to the standard normal form, and then we'll have to look for that value in the table. So I'm once again back here for the calculations. Remember, the transformation was x minus mu by sigma. So 50 is the value of x, minus mu is 35, divided by sigma, which is 7. This comes to 2.14. No surprises, these values are identical because the mean was sitting at 0. Now, can I locate this value in the table and find out the probability corresponding to it? Would that match this value? Let's check. So we are back at the table. And right now, if you see, the last row represents 2.1. We were looking for 2.14, this time positive. Earlier it was negative. 2.14 positive. Well, it doesn't look like 0.016. In fact, the value that we have is 0.98382. Why is the value so different? This is what you have to understand. The nature of the problem is different. All these tables always calculate the area from left to right. So right now, what you're getting an answer for is the question, which is the purple region here. It calculates the area from left to right, which means it's telling you the values up to 50. What is the probability that the batsman scored up to 50? But you were asked, what is the probability that the batsman scores greater than 50? Now, it's not a big hassle for us because we know the total area under the curve is 1. So if the total area is 1, and I already know the purple area, which is that 0.983, I just have to subtract that value from 1. And I will get this gray shaded region. If I add this purple region and the gray region, this should add up to 1, right? So if I already know that this purple region is 0.983, and I subtract it from 1, I'll get the gray region. Okay, so let's do that. We have to do 0.98382. See, this is an identical answer that you got. So we could solve that using the trick because luckily there was a complete symmetry here. But if somebody asks you for any other value also for a greater than kind of problem, for example, they can ask you, what is the probability that a score is greater than 45? You can just do this kind of calculation, do the transformation here, bring it to a standard normal form, and then go ahead and look for that value in the table. Keep this in mind that you have to do a 1 minus in a greater than scenario because all the tables calculate the area from left to right. Can this be done quickly using Excel? Let's try the norm.dist function one more time. I will have to put the value that I'm looking for, that's 50, and I have to look for the mean, which is 35. I have the standard deviation, which is 7, and I have a cumulative scenario. Why cumulative? Because we are calculating an area over a range, not a point. This is the same as what we were getting earlier. Still not the answer because we have to subtract this from 1. Again, you can see there's a little bit of a difference in these values because the table only followed a 2-point precision. We could only look for a value of 2.14. And we got the answer. Whereas when we look at Excel, it's considering this complete value when doing the calculation. But to the third place of decimal, the values are identical. Now let's move to the third scenario, which is the in-between kind of problem. What is the probability that the batsman would score anywhere between 25 to 40? I didn't maintain the symmetry on purpose here so that you don't get used to of seeing only the symmetric problems. So anywhere between 25 to 40. Now this problem can be broken into 2 steps. If you're somehow able to find this larger area, which is up to 40, this from the negative infinity to this line here up to 40, and from there you subtract this area, which is this white region to the left of 25. So you will get this gray region. To get this larger area here, from there you subtract this smaller area, you will get the gray shaded region. Essentially, I'm saying it's like this. So the larger area up to 40 is this much. Area less than 25 is this much. So if you subtract from 40, you subtract the area up to 25, you will get the area between 25. And that's what we have to do. So I will not do it using the table this time because I've already shown you 2 examples. I will directly do it using Excel. All right, so we're back here. So can we use the norm.dist? The upper limit is 40. The mean is 35. The standard deviation is 7, and it's a cumulative area. And from this, I have to subtract again another norm.dist, which will be nothing but 25, because that's the value we are checking for, 35 for the mean, 7 for the standard deviation, and 1 for the cumulative region, right? If I don't put 1 here at the end, it'll just give me the value of that probability density function, that scary formula that I showed you some time back, right? So let's just do this here. This is coming to 0.6859. So the probability that the batsman will score anywhere between 25 to 40 runs is 68.5%. And sometime I'll show you how to solve these problems in Python as well. In fact, the tool doesn't matter. This is all standard. All these tools at the back end, whether it be Excel or Minitab or SPSS or any other tool for that matter, they just have the same normal distribution table built in. It's just that they can afford to have a higher precision there, which, of course, in a printed table, you'll not have to that extent. Okay, now let's take the last leg of problems. So far, we've been answering for the probabilities given the thresholds. For example, what is the probability if it scores less than 20? What is the probability if it scores more than 50? What about the scenario when they give you the probability and ask you for the score thresholds? For example, let's say in the same question, we twist it by saying, what is the score threshold below which he has scored only 10% of the times? above which he's scored only 15% of the time. What has changed in this case is that they're giving you a probability and they're asking you to give the value, which means that inside the table now, we will have to look for this probability value of 10% or 0.10 and correspondingly derive the z-score. And using that z-score formula, then we will have to answer for x here. Let me show you. We are looking for 10%. Now, this is the place where you're closest to 10%, 0.10, with some extra digits, of course, but this is the place where you're closest to 0.10 in the table. What does this probability belong to? Negative 1.2 is the same row, and this is 8. So negative 1.28 is the z value corresponding to the probability of 10%. So in this formula, we know the value is negative 1.28. We know this value is 35. We know this value is 7. Can we find out x? That's what we have to do. Let's do that quickly. So we've been given negative 1.28. We have to multiply the standard deviation here, which is 7. And we have to add the mean here to get the value of x. We're just applying the same formula, multiplying the standard deviation here, and then bringing it to the right, bringing the mean to the right and adding it. This comes to 26.0. Is there a formula for this in Excel as well? Yes, there is something which is known as norm inverse. It knows, in this case, I'll be given the probability and I have to find out the threshold corresponding to it. So the mean is 35 and standard deviation is 7. See, again, there's a little bit of a difference in the values because of the precision. So this was the case when you were asked about the less than type of problem. So what is the threshold below which lie the 10% of the area? What if they ask you for a greater than region? For example, what if they ask you above which he's scored only 15% of the time? Now, again, this will be a little tricky. You will have to find out the value in the probability table corresponding to not 15%. Because remember, the table goes from left to right. So when they're asking you for a greater than problem and giving you a value here, which is 15%, you know below it lie 85%. If they're asking you a greater than problem, you will have to do a 1 minus to this value to be able to get converted to the area from left to right. Similarly, just some time back, we discussed this. In this case, the areas are given. They're asking you for this value. So I will have to convert this to the bottom 85%, ahead of which is only 15%. Can we quickly go to the table and find out the area corresponding to 85%? So let's try to locate 85% somewhere here. Where is that? This is for the first time where you see 0.85, right? So this is 1.04. So 1.04 is the z value corresponding to this probability. Now you have to do the calculation. So what would I do? 1.04 again multiplied by the standard deviation and bring the mean this side. This is 42.28. That's your answer. 42.28 is the score above which he has scored only 15% of the time. 26.04 was the score below which he scored only 10% of the times. Let's do this again using the norm inverse. So if I come to this and I put the probability, again, remember, I have to put 0.85 and not 0.15. For a greater than problem, change the probability to 1 minus all the time. Make it 35, make it 7 here, and get the answer, which is 42.25, 42.28, again, very close. I know some of you who are watching this video must be learning data science. You may have started working on Python by now. Let me quickly show you how these problems are solved using Python. So in Python, you have a library called scipy, which has a module called stats, and that's what you're going to use to solve these problems. The names of the functions might vary, but essentially it has the same normal distribution table at the back end. The function is cdf.cdf, which is cumulative distribution function. And we used to pass a 1 in Excel formula, if you remember, for this only. So you just have to mention the value. If the first problem, if you remember, was straightforward problem for probability, what is the probability the player has scored less than 20? So you put 20 here. So location here is mean, and standard deviation is something that you have to mention as the scale. This is same as this formula. And if you see the answers will also tally 0.0160 or 1.60%. We got the same answer earlier. Similarly, probability that the player scores more than 50. Again, you know you will straight away not get this answer. It'll give you the region up to 50, and you have to do a 1 minus, which will be the same as the earlier answer. We saw this as well. Between 20 to 40, again, you have to take the upper region, which is up to 40, upper value, which is up to 40, and then you have to subtract the lower value, which is up to 25, and you will get this answer. I can quickly show you these are the same answers that we got some time back. 3.0160 and 0.0160, and the third answer was 0.685, which is what we're getting here, 0.685. Now, the last set of questions, if they ask you for the inverse, which means they give you the probability and ask you the values correspondingly, you can use a PPF function in this case. So this PPF function here is, which is the inverse of CDF. Now, for the less than 10% scenario, to just mention 10%, location is mean, standard deviation is a scale here. This is the nomenclature that this library follows. In fact, see, the reasoning behind this nomenclature is because a normal distribution will sit at a point, the center of a normal distribution will sit at a point which is represented by the mean. We saw that, right? You say x minus mu by sigma. Sigma here is kind of scaling this. It's kind of trying to show you how many standard deviations can be fit between x, which is a point on the normal distribution curve, and mean. This has been explained really well in the earlier normal distribution video we did. So you may refer to that video in case you want. Coming back to the notebook, we are using PPF and straight away we get the answer is 26.02, which is the same that we got here, approximately the same. In fact, Excel was identical and the manual calculation was pretty close. Now the next piece, with score above which the player has scored only 15% of the times, you use PPF, but remember, you will not be using 0.15 here, you'll be using 0.85 here. Reason being, this is a greater than kind of problem, right? So use 0.85 here because the normal distribution curve area would always be calculated from left to right, align it, and then you will get the answer. This is 42.25, 42.28 was the manual calculation, and 42.25 was the calculation in Excel. So irrespective whether you're doing it manually in your exams or you're allowed to use some tools, you can see if you are clear with the concepts, you will get identical answers. If this video has given you some clarity on normal distribution, please ensure that you give it a like, subscribe to this channel, and share it with all those who might benefit. Thank you.